We'll start in a minute. We'll continue the test 4 review today. Tomorrow is test 4, and you can also take a test 4 practice on Newton. So the first thing we'll do today is solve the equation by completing the square. So if the directions on a problem say solve the equation by completing the square, that means there's work to show. So the first thing we can do is add 24 to both sides. So we get 4x to the second plus 32x equals 24. And then we want to divide every term on both sides by 4. And we'll get x squared plus 8x equals 6. And now that the coefficient of x squared is 1, we can create a perfect square trinomial. So to do so, we're going to take 1/2 of 8, which is 4, and square that number. 4 squared is 16. So in the next step, we add 16 to both sides. And now the left-hand side is a perfect square trinomial. So when we factor it, we can write it as a single binomial squared, x plus 4 squared, and the right-hand side is 22. And now we apply the square root property. X plus 4 equals positive and negative square root of 22. The square root of 22 cannot be simplified, so we just subtract 4 from both sides. We write the solutions as x equals negative 4 plus and minus the square root of 22. Okay, the next problem, number 2, write the standard equation for the circle x squared plus 8x plus y squared minus 10x. Whoops. This should be a minus 10y equals 8. I guess we could have made it work with the minus 10x. We would just get a different circle than the one intended. Okay, but we'll rewrite this x squared plus 8x. Leave some space for the completing the square part, plus y squared minus 10y. Leave space, and then equals 8. Okay, so since the coefficient of x squared is 1, we can take 1/2 of 8, which is 4, square that number, which is 16. So we'll start in a few seconds by adding 16 to both sides. This is now a perfect square trinomial. And then y squared minus 10y, the coefficient of y squared is 1, so the number that we need to add to y squared minus 10y to get a perfect square is what we get when we square 1/2 of negative 10. 1/2 of negative 10 is negative 5, and when you square that number, you get 25. So we add 25 to both sides. And then in the next step, we can write the standard equation. So x squared plus 8x plus 16 is equivalent to x plus 4 squared, and y squared minus 10y plus 25 is equivalent to y minus 5 squared. And then add the numbers on the right-hand side. 8 plus 16 is 24. 24 plus 25 is 49. The directions for number 2 don't call for identifying the center, but we might as well just for practice. The x-coordinate of the center is negative 4. The y-coordinate of the center is 5. The radius is the positive square root of 49, which is 7. Okay, and the next problem, well, this is another equation of a circle. Write the circle x squared minus 3x plus y squared minus 7y equals 3/2 in standard form. And then write the center as an ordered pair and find the radius. Okay, so this time fractions will be involved, but I'll write x squared minus 3x with space before I write plus y squared minus 7y, and then leave some space before you write equals 3/2. Okay, we want to find a number to add to x squared minus 3x to get a perfect square trinomial. So we take 1/2 of negative 3, which is negative 3/2, and we square negative 3/2. Okay, so when you square negative 3/2, you get positive 9/4. So we add positive 9/4 to both sides. And then we're going to complete the square on y squared minus 7y. So this time we take 1/2 of negative 7. 1/2 of negative 7 is negative 7/2. And then we square negative 7/2, and we get positive 49/4. So we add 49/4 to both sides. This perfect square trinomial, x squared minus 3x plus 9/4, is equal to a binomial squared. The binomial has to have x in it. And what follows x? It's the same number we got when we took 1/2 of negative 3. So 1/2 of negative 3 is negative 3/2. So we write x minus 3/2 quantity squared. And then the other binomial squared, this has to have y in the binomial. And the number that follows is 1/2 of negative 7, or negative 7/2. So we write minus 7/2. Then on the right-hand side, we'll do the arithmetic up here. We need a common denominator before we can add all of those fractions. So we'll replace 3/2 with 6/4. And I'll go ahead and add these two. This just adds up to 58/4. And then when we add 6/4 to 58/4, we get 64/4. And that reduces to 16. 64 divided by 4 is 16. Okay, so here's the standard equation for that circle. And we'll write the center as an ordered pair. The x-coordinate of the center is 3/2. The y-coordinate of the center is 7/2. And the radius is the positive square root of 16, which is 4. Okay, and the next problem, number 4, solve the equation x squared plus 8x plus 20 equals 0. Okay, so x squared plus 8x plus 20 equals 0. Well, let's use the quadratic formula on this one, where a is 1, b is 8, c is 20. Okay, so x equals -8 plus and minus the square root of 8 to the second minus 4 times 1 times 20, all divided by 2 times 1. And then we do the arithmetic, -8 plus and minus the square root of some number, all divided by 2. Inside the square root, 8 to the second is 64, and we're subtracting 4 times 1 times 20, 64 minus 80. So the discriminant is negative. That means the solutions are 2 different non-real numbers, non-real complex numbers. So we'll take this out a little further, -8 plus and minus the square root of -16 divided by 2, all divided by 2. And this one works out pretty nicely. The square root of -16 simplifies to 4 times I, where I is the square root of -1, all divided by 2. And then the greatest common factor of every term in the numerator and the denominator is 2. So we can divide everything by 2. We get x equals -4 plus and minus 2i. Okay, the next page will involve a couple of word problems. So on this one, a projectile is fired upward. Its height h in feet after t seconds is h equals -16t to the second plus 64t plus 48. Find the number of seconds it takes for the projectile to hit the ground. When the projectile hits the ground, the value of h will be 0 because h represents the height above the ground. So we just end up solving a quadratic equation, replace h with 0, set it equal to -16t to the second plus 64t plus 48. We can use the quadratic formula with the numbers a equals -16, b equals +64, and c equals 48. But those numbers are pretty large, and we can make it easier on ourselves if we note that -16, 64, and 48 are all divisible by 16. But even more than that, generally, it's nice to have a positive coefficient of the variable squared term. So if we divide every term on both sides by -16, we'll get an equation that will be simpler to solve, even though the solutions are the same. So 0 divided by -16 is still 0. Then divide every term on the right-hand side by -16, and we get t squared minus 4t minus 3. So as I said, the solutions to this second equation are exactly the same as the solutions to the equation above it, but with the numbers pared down, the arithmetic will be easier. So let's use the quadratic formula with a equals 1, b equals -4, and c equals -3. So we get t equals the negative of -4 plus and minus the square root of the number -4 squared minus 4 times 1 times -3. And this is all divided by 2 times 1. Then we'll do a little arithmetic. The negative of -4 is 4. And then plus and minus the square root of some number, all divided by 2. Okay, so inside the square root, when we square the number -4, we get positive 16. And we're subtracting 4 times 1 times -3. So we're subtracting -12. And when you subtract -12, you get plus 12. So now we can write t equals 4 plus and minus the square root of 28, all divided by 2. I want to point out at this point, we want t to be we're expecting t to be a positive number, not a negative number, since t represents the number of seconds going into the future. So we can ignore the solution that we get by subtracting because that solution will be negative. So I'm just going to write t equals 4 plus the square root of 28, all divided by 2. And then the square root of 28 can be simplified. So we write 4 plus the square root of 4 times the square root of 7, divided by 2. And then we'll squeeze a little bit more in. 4 plus 2 times the square root of 7, all divided by 2. Every term in the numerator has a common factor of 2 with the denominator. So if we just divide everything in the numerator by 2, we get 2 plus the square root of 7. The square root of 7 is a number that's between 2 and 3. So the t-value is something between 4 and 5 seconds. So if you convert this to a decimal, you're expecting a number that's greater than 4 but less than 5. Okay, and the next problem, number 6. Okay, this is a work problem. Jim and Bob can plant a garden in 4 hours when working together. Working alone, Bob takes 2 hours longer than Jim. Find the amount of time it takes each to plant the garden alone. Okay, this is a work problem. Equations in work problems have the form rate times time equals 1. Well, 1 refers to the job or the task that they are accomplishing. And we have 3 scenarios. Jim and Bob can work together, or they can each work separately. And when they work together, we're told that they can plant a garden in 4 hours. So when they work together, we'll write Jim's rate plus Bob's rate times 4 hours, or in 4 hours they can plant a garden. And then we're given information about what they do when they work separately. So we're going to write down an equation of that form, rate times time equals 1 for Jim and also 1 for Bob. Okay, we're told that Bob takes 2 hours longer than Jim. So we need to pick a variable to represent the amount of time it takes one or the other. And then using that variable and this information about Bob taking 2 hours longer, we can represent the amount of time that the other takes. So we have to pick, I'm going to pick capital T to represent Jim's time measured in hours. So Jim takes T hours. So for Jim, we write his rate times T hours equals 1. So this means it takes Jim T hours to plant 1 garden. Bob takes 2 hours longer than Jim. So for Bob, his rate multiplied by T plus 2 equals 1. What we want is an equation whose only variable is T. So we've done what we're going to do next. We've done a number of times throughout the semester for work problems. We're going to solve each equation for the rate. Jim's rate plus Bob's rate is 1/4, meaning that they can plant 1/4 of the garden per hour. Jim's rate is 1/T, and Bob's rate is 1/T plus 2. And then we're going to replace Jim's rate with 1/T in this equation. So we get 1/T plus Bob's rate, which is 1/T plus 2. And the sum of the rates is 1/4. So what we do now is identify the least common multiple of the denominators and multiply every term on both sides by the least common denominator. Okay, so the least common multiple of the denominators is just 4 times T times the binomial T plus 2. Think of that as being over 1 if it helps. When we multiply this least common denominator by 1/T, the T's cancel. T divided by T is 1, so we're just left with 4 times T plus 2. And then we multiply it by 1/T plus 2. This time the binomial T plus 2 from the numerator cancels with the same binomial factor in the denominator, and we're just left with plus 4 times T. And then on the right-hand side, 1/4 times the least common denominator, the 4's cancel, and we're left with T times the binomial T plus 2. The resulting equation is a quadratic equation. So we'll multiply everything out, combine like terms, and set one side equal to 0, and then decide how we're going to solve that quadratic equation. So on the left-hand side, 4 times the binomial T plus 2 is 4T plus 8, and then plus 4T. And then on the right-hand side, T times the binomial T plus 2 is T to the second plus 2T. Okay, we'll combine like terms on the left-hand side. 4T plus 4T is 8T. And then plus 8, that's equal to T to the second plus 2T. We'll make the left-hand side 0 by subtracting 8T from both sides and also subtracting 8 from both sides. And we'll get 0 equals T to the second minus 6T minus 8. Okay, it turns out we can solve this quadratic equation by factoring, but you can also use the quadratic formula, or you can solve it by completing the square. You get to decide, but since it factors so nicely, I'll just write down the 2 factors. One factor is, oh wait, so I guess I'm wrong. Anyway, let's use the quadratic formula where A is 1, B is -6, and C is -8. Okay, so t equals the negative of -6 plus and minus the square root of the number -6 squared minus 4 times 1 times -8. This is all divided by 2 times 1. Okay, so we'll do a little arithmetic. The negative of -6 is 6, and then plus and minus the square root of some number, all divided by 2. Okay, so inside the square root, the number -6 squared is 36, and we're subtracting 4 times 1 times -8. So we're subtracting -32. That's the same as adding 32. Okay, I need more space, so I'm going to write down what I have here on another piece of paper. Okay, so on another piece of paper, this is where we are. Notice that, well, 36 plus 32 is 68. And the square root of 68 is a number that's larger than 6. And since we want t to be a positive number, we can ignore the solution that we get by subtracting. So in the next step, I'll just write t equals 6 plus the square root of 68, all divided by 2. And we can simplify the square root of 68. 4 times 17 is 68. So we can write this as 6 plus the square root of 4 times the square root of 17, all divided by 2. And then t equals 6 plus 2 times the square root of 17, all divided by 2. And then divide every term in the numerator by 2. We get 3 plus the square root of 17. The square root of 17 is a little bit bigger than 4. It's a little bit bigger than the square root of 16. So this is a little bit bigger than 7. So Jim would take 3 plus the square root of 17 hours, which is a little bit bigger than 7 hours. And Bob takes 2 hours longer. So Bob's time is 2 hours more than this. So 3 plus 2 is 5. So 5 plus the square root of 17 is a little bit bigger than 9 hours. So if you use a calculator, you can get a decimal approximation for those numbers. Okay, moving on. Number 7, find the distance between the points -2, -3, and 4, -7. Okay, so the distance formula, remember, if we want to find the distance between x1, y1 and x2, y2, then the distance between those 2 points is the square root of x2 minus x1 quantity squared plus the quantity y2 minus y1 squared. Take the square root of all of that. And then when assigning x1, y1 and x2, y2, it doesn't matter which of those two you pick. Okay, so we'll focus on the x-coordinates first. This x-coordinate is -2. The other x-coordinate is 4. So the square root of the quantity -2 minus 4 squared, and then plus, now we focus on the y coordinates. This one is -3, the other one is -7, so we can write -3 minus -7 quantity squared. So when negatives and subtraction is involved, you have to be careful with the arithmetic. Okay, here inside the parentheses, -2 minus 4 is -6. So we're going to square the number -6 in the next step. And then we're adding -3 minus -7. That's equivalent to -3 plus 7. -3 plus 7 is 4. So we have 4 squared. And then in the next step, the number -6 squared is 36, and we're adding that to 4 squared, which is 16. And then 36 plus 16 is 52, so we have the square root of 52. And this can be simplified. The largest factor of 52 that's a perfect square is 4, so we can write this as the square root of 4 times the square root of 13, because 4 times 13 is 52. And then the simplified answer for the distance is 2 times the square root of 13. Okay, and the next problem, number 8. A right triangle's hypotenuse is 10 feet. One leg is 4 feet longer than the other leg. Find the length of the short leg and round that to the nearest tenth of a foot. Okay, so sketching a diagram might help for this right triangle. We're told that the length of the hypotenuse is 10 feet. And one leg is shorter than the other, so I'll label the short leg with x feet. And the long leg is 4 feet longer than the short leg, so we get x plus 4. And we want to find the length of the short leg, so the way I have assigned variables, we want to solve for x. So here we'll use the Pythagorean theorem, which says if you square the length of the hypotenuse, 10 squared, that's equal to the sum of the squares of the lengths of the two legs. So we're squaring the short leg, x squared, and then squaring the long leg. And then we do algebra and arithmetic. 10 squared is 100. That's equal to x squared. And then when we square the binomial x plus 4, we get x squared plus 4x again, and then plus 16. Okay, our equation is just a quadratic equation. So in the next step, I'll do a few things at once. We'll subtract 100 from both sides, and we'll combine like terms on the right-hand side. So we'll get 0 equals 2x squared plus 8x, and then minus 84, because 16 minus 100 is 84. And now we just need to solve this quadratic equation. Note that every term on the right-hand side has a greatest common factor of 2. So if I divide every term on both sides by 2, I won't have to deal with so many numbers. We're getting rid of some of the clutter that's in the way. Okay, so now we can use the quadratic formula with a equals 1, b equals 4, and c equals negative 42. So x equals negative 4 plus and minus the square root of 4 squared minus 4 times 1 times negative 42. And this is all divided by 2 times 1. Well, let's observe in the square root, inside the square root, we have 4 squared, which is 16, and we're subtracting a negative number. We're subtracting negative 168. So this becomes 16 plus 168. And the square root of that number, when subtracted from negative 4, is going to be negative. But we don't want a negative solution. We want a positive solution. So I'll just write the solution we get when we have negative 4 plus the square root of this number. Okay, so 4 squared is 16. And like I said, we're subtracting a negative 168. So that's 16 plus 168, which is positive 184. And this is all divided by 2. Okay, well, 4 is a factor of 184. That is a perfect square. So I'm going to write this as negative 4 plus. And then if you'll allow me, the square root of 4 is 2. So I'll just write negative 4 plus 2 times the square root of 46. And this is all divided by 2. Okay, I'm sort of running out of space here, but if you divide every term in the numerator by 2, then we're going to get x equals negative 2 plus the square root of 46. Okay, then you can use your calculator to get a decimal approximation of that number. Just compute the square root of 46 and then subtract 2 from it. Round it to 1 decimal place, round it to the nearest tenth, and that will be the length of this short leg. Okay, the next problem, solve the equation 7x squared equals 35 by the square root property. Okay, so first divide both sides by 7, and we get x squared equals 5. And then the square root property, since x squared equals 5, x equals positive and negative square root of 5. So that's all there is to that. The next problem, solve the equation 3x squared minus 2x minus 1 equals 0. So let's try the quadratic formula with a equals 3, b equals negative 2, and c equals negative 1. Okay, so x equals the negative of negative 2 plus and minus the square root of the number negative 2 squared minus 4 times 3 times negative 1, all divided by 2 times 3. Then we'll do the arithmetic. The negative of negative 2 is positive 2 plus and minus the square root of some number all divided by 6. So inside the square root, the number negative 2 squared is 4. And we're subtracting 4 times 3 times negative 1. We're subtracting negative 12. So that's equivalent to adding 12. So now we have x equals 2 plus and minus the square root of 16, all divided by 6. The square root of 16 is 4, so we have 2 plus and minus 4 divided by 6. So now, since we can simplify further, we'll write the solutions separately. One solution we get by, in the numerator, 2 minus 4 is negative 2 over 6, which is negative 1/3. And the other solution, 2 plus 4 in the numerator is 6. 6 divided by 6 is 1. Okay, so what this means is since the solutions are rational numbers, 1 is an integer, but integers are rational numbers. That just means that we could have solved by factoring. Okay, moving on. So on this one, the center of a circle is negative 3, 4. The x-coordinate is negative 3, and the y-coordinate is 4, and its radius is 11. And this just says write the standard equation for the circle. So first we begin by writing x minus the x-coordinate of the center, x minus negative 3 squared, and then plus y minus the y-coordinate squared, and that's equal to the radius squared. Okay, this is a good start, but we want to take it a little further. X minus negative 3, we write as x plus 3. So we have x plus 3 squared. And then the y minus 4 quantity squared is already the way that we want it. And then 11 squared is 121. So this is the equation that we want to write for the standard equation of that circle. Okay, and then in the next few examples, we have simplifying radicals. So simplify the square root of 147y to the 19th. The largest factor of 147, that is a perfect square, is 49. 49 times 3 is 147. And then the largest factor of y to the 19th, that's a perfect square, is y to the 18th. If an exponent is even, it's considered a perfect square. So we can rewrite this as the square root of 49y to the 18th times the square root of 3y. And then the square root of 49 is 7. The square root of y to the 18th is y to the 9th, because we divide the exponent 18 by the index 2. 18 divided by 2 is 9. And so the simplified answer is 7y to the 9th times the square root of 3y. This is as far as we can simplify that radical. Okay, on the next one, the square root of 25x to the 12th divided by the square root of 2y. We can simplify the numerator. The square root of 25 is 5, and the square root of x to the 12th is x to the 6th. But we still have this square root of 2y in the denominator. So that means in order for this to be simplified, we cannot have a square root in the denominator. So the technique is to multiply by 1. And in this case, the form that 1 takes is the square root of 2y divided by the square root of 2y. Okay, so the next step is the simplified answer, 5x to the 6th times the square root of 2y in the numerator. And in the denominator, the square root of 2y times the square root of 2y simplifies to 2y. So now we no longer have a square root in the denominator. This is the simplified form. Okay, a couple of more radicals. Simplify these radicals. The fourth root of 32m to the 12th. The largest factor of 32 that is a perfect fourth power is 16, because 2 to the 4th is 16. M to the 12th is a perfect fourth power because the exponent 12 is a multiple of 4. So we can rewrite this as the fourth root of 16m to the 12th times the fourth root of 2. And the fourth root of 16 is 2. The fourth root of m to the 12th is m to the third, because we divide the exponent 12 by 4. 12 divided by 4 is 3. And so the simplified answer is 2 times m to the third times the fourth root of 2. Okay, and the next one, simplify the cubed root of 54n to the 7th divided by the cubed root of 2n. Well, we note that if we write this using the quotient property radicals as a single cubed root of 54n to the 7th over 2n, then the fraction simplifies, so we just get the cubed root of 27n to the 6th. And the cubed root of 27 is 3, because 3 to the third is 27. And the cubed root of n to the 6th is n to the 2nd, because the exponent 6 divided by the index 3 is 2. So this simplifies to 3n to the 2nd. Okay, the next page, solve x squared plus 5x minus 14 is less than 0. So we want to find the endpoints. The endpoints of the intervals are the real valued solutions to x squared plus 5x minus 14 equals 0. And note, in this case, x squared plus 5x minus 14, this can be factored. So one factor is x plus 7. The other factor is x minus 2. And the inequality is less than 0. So if one side is 0, and if we can factor the other side, we can use the factors to identify the endpoints. So one endpoint is -7, and the other endpoint is +2. So when we solve these kinds of inequalities, we plot the endpoints on the number line. The two endpoints divide the number line into 3 separate intervals. So in the first interval, I'll pick x to be -8, and then I'll use the factored inequality. Replace x with -8. -8 plus 7 is -1. -8 minus 2 is -10. -1 times -10 is +10, but the inequality less than 0 is false. Okay, so none of the numbers in that first interval are solutions. So if in the second interval, between -7 and 2, we can pick 0. And then in the original inequality, even though the factored one also works, in the original inequality, replace every x with 0. And this time we get -14 less than 0, which is true. So the numbers between -7 and 2 are solutions. And then in the third interval, pick a number bigger than 2, like 3. And then I'll use the factored form again. Replace x with 3. 3 plus 7 is 10. 3 minus 2 is 1. And this is a positive number. Less than 0 is false. So none of the numbers from 2 to infinity are solutions. And since the inequality is just less than, it's not less than or equal, the endpoints are excluded. So graphically, we would put a parenthesis at each of the endpoints. And then the interval notation for this is parenthesis -7 comma 2 parenthesis. And the algebraic notation is -7 less than x, which is less than 2. Okay, let's at least get started on this one. Number 16 is the same kind of inequality as number 14 up there. And it's already factored for you, so you can identify the endpoints, -2 and 4. And this one is not so bad either. This is a rational inequality. One side is 0, And we can easily identify the endpoints. The x value that makes the numerator 0 is 2. The x value that makes the denominator 0 is -3. So we just plot those numbers, -3 and 2. And we'll keep going until we run out of time, which is less than a minute. In the first interval on the left, we can pick x to be -4. And in the inequality, replace x with -4. In the numerator, -4 minus 2 is -6. In the denominator, -4 plus 3 is -1. And this is a positive number, but a positive number less than or equal to 0 is false. So none of the numbers from negative infinity to -3 are solutions. In the middle interval, we can pick 0, replace every x with 0. This time we get -2 over 3. A negative number less than or equal to 0 is true. So yes, the numbers from -3 to 2 are solutions. And then in the third interval, pick x to be 3. Replace every x with 3. In the numerator, 3 minus 2 is 1. In the denominator, 3 plus 3 is 6, but 1/6 less than or equal to 0 is false. So none of the numbers greater than 2 are solutions. We always exclude endpoints that come from the denominator. So -3 is excluded. So graphically, we put a parenthesis at -3. But in this case, we're including the endpoint 2, because if you replace every x with 2, you get 0 less than or equal to 0, which is true. So put a bracket at 2. Okay, so just a couple more things. The interval notation for the solution set is parenthesis -3 comma 2 bracket. And the algebraic notation, -3 is less than x, which is less than or equal to 2. Okay, so we're out of time. Tomorrow is the test. So we'll talk again then.